हेलो फ्रेंड्स, इस वीडियो में हम ऑब्जेक्टिव 1 फ्रॉम एचसी वर्मा 11th पोर्शन चैप्टर 2 विच इज फिजिक्स एंड आई थिंक मैथमेटिक्स या को डिस्कस करेंगे. तो लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन. A vector is not changed if obviously if we slide it parallel to itself it will not change. In any other case, if it is rotated, obviously it will change, its direction will change, so vector will change. If it is multiplied by any arbitrary scalar, its magnitude will change. If it is cross multiplied, its direction will change. Okay, so in ABC it will change and in D it will not. Next question. Which of the set given below represents the magnitude of three vectors adding to 0? Okay, so if any pair can represent three sides of a triangle, even in the limiting case, then the resultant can be 0. Let's start with first 2, 4, 8. They cannot represent a triangle because 2 plus 4 is 6, which is less than 8. Sum of two sides must be greater or equal to the third side. Similarly, in this question, 4 plus 8 is 12, which is less than 16. Yeah, in this case, 1 plus 1 can be 2. Okay, so this can represent or this pair can give you 0 resultant, and this pair can also not give you cannot give you a 0 resultant. So we'll go with C. Okay, and we can have a look at the diagram how it will give you 0 resultant, as 1 and 1 will be parallel to each other and 2 will be just opposite, so they will give 0 resultant. Okay, let's move on to the next question, which is question number 3. A and B making an angle alpha. The resultant of A and B makes an angle alpha with A and beta with B. So if beta is greater than, in all four options beta is greater than alpha, so this may be the diagram. This is vector A and this is vector B. Resultant is shown by the dotted vector. This is an angle alpha which is making with vector A, and this is vector B with which it's making an angle beta. So what is happening? The resultant is closer to the larger magnitude vector. Okay, so it will be closer to A. If it is closer to A, only then beta will be greater. So if beta is greater, resultant will be closer to A and alpha will be smaller. So A must have larger magnitude than B. So we'll go with option C. So we'll go with option C, which says if beta is greater than alpha, obviously the magnitude of A will be greater than magnitude of B. Okay. The next question says component of a vector. Obviously, component of a vector cannot be greater than the magnitude of vector itself. It may be either equal to the magnitude or less than that. Okay, so it is always less than that. It's not correct. It may be equal also. It is always greater. No, it is impossible. It is always equal. Yes, it may be, but not always. Okay, so we'll go with option D. In fact, A and C both are partially correct. Okay, if we remove these word always, but in single option correct, we'll go with D. Fifth, a vector points vertically up and B points towards north, their cross product. Okay, so let's have a look at the diagram. This dot is shown by vector A, which is uh, above this or out of the plane of paper, and this is north, this is south, east, west. So we can say A can be represented by K cap, which is out of the plane of paper, and north is J cap y axis. So K cross J, obviously A cross B हमें करना है, so K cross J will give you minus I cap, which is the left direction, which is west. Okay, so A cross north or A cross B, which is towards north, will be west. Moving on to the next question. The radius of a circle is stated as 2.12 centimeter. Its area should be. So when you will calculate, you will get this answer D. But taking care of significant figures, whenever you multiply two things, the answer should have a minimum number of significant figures which are in the values we are multiplying. So answer will have only three significant figures, which is up to one decimal place, obviously. So B will be the answer because it has only three decimal, sorry, three significant figures. Okay, and the product answer should have three significant digits as 2.12 also have three significant digits. Now we will discuss objective 2 from the same chapter. Question number first says a situation may be described by using different set of coordinate axes having different orientation. Which of the following do not depends on the orientation of the axis? Obviously scalar, because scalar is independent of direction, and component of a vector will change if you change the x and y axis or rotate them. A vector will not change as a whole. Okay, its component will change but the vector as a whole will not be changed. The magnitude of vector, obviously it is independent of the direction or independent of the orientation of axes. So scalar independent of direction, a vector, and option D, which is magnitude of a vector, are independent of the orientation. Okay, the component of a vector will depend on the orientation. Okay, if C is equal to A plus B, C is the third side of the triangle, then C is always greater than A. No, it is not a correct statement. Is it possible that third side is smaller than the both sides? Yes, it is possible, obviously. C is always equal to A plus B. C is never equal to A plus B. Both the statements are incorrect. C need not to equal to A plus B, but it may be equal to A plus B. Okay, can look at the solution. C is equal to A plus B. C being the third side, it can be smaller than both the sides. Okay, only option correct is B. Let the angle between two non-zero vectors A and B is 120 and their resultant is C. Okay, C is basically A plus B. So we have to choose which of the option is correct. C is A plus B, as C being the this is the solution for third. C is equal to A plus B, and we know the angle between A and B, so the magnitude of C or magnitude of A plus B will be this. Cos 120 is minus half, so we'll have A square plus B square minus AB whole root will be the magnitude of C. Whereas while comparing with A minus B magnitude, we'll find out the magnitude of A minus B as A square plus B square plus AB. So obviously the magnitude of A minus B will be greater than the magnitude of A plus B, which is C. Okay, so we can say C is smaller than A minus B. Okay, magnitude of C must be less than A minus B, as both are non-zero vectors. Okay, obviously this A square minus B A square plus B square minus AB will be smaller than A square plus B square plus AB. Okay, and there's a general statement: if angle between two vectors is greater than 90, if two vectors are inclined at obtuse angle with each other, their sum will be smaller than their difference. Okay, if angle is 90, their sum will be equal to their difference in magnitude terms, and if angle between the vectors is less than 90, their sum will be greater and their difference will be smaller. Moving on to the next question, which is the x component of the resultant of several vectors is equal to the sum of x component of vectors. Perfectly right. This is how we define resultant. that if A is equal to B plus C, then AX, X component of A is sum of X component of B and C. The next statement says may be smaller than the sum of magnitudes of the vector, obviously, because the components may be smaller than the each vector. So B is also correct. May be greater than the sum of magnitude of vector. No, it is not possible because X component will not be greater than the vector itself. So the sum of X component can never be greater than the sum of magnitudes of vector. May be equal to the sum. Yes, it may be equal to the sum of magnitudes if all the vectors are along x-axis only. Okay, let's say 2i plus 3i. 2i also have one component which is 2 and magnitude is also 2, and 3i is also has magnitude 3 and it has only one component. So when we'll add, we'll get x components as 5 and their sum is also 5. So option D is correct when the vectors has only x components. Okay, and option question number 5, the magnitude of vector product of two vectors A and B may be, uh, obviously the vector product is defined as AB sine theta. So we can say the magnitude of cross product will be AB sine theta, and sine theta can never be greater than 1, so it must be less than or equal to AB. Okay, so it can never be greater than magnitude of cross product or dot product also can never be greater than the individual product of magnitudes of vector. Can be greater than, wrong. Equal to, yes, it can be equal to provided sine theta should be 1. Less than, obviously it can be equal to 0. Obviously if sine theta is 0, it will be 0. So B, C, D are the correct answers. Okay, thanks.